Hi, my name is Shahroz Ahmed, and in this video we are going to practice some of the SAT physics questions. So let's start off with the first one. In this question it says that we have been given a diagram, and it says a beam of light is incident on a rectangular opening in front of a box as shown in the side view above. The back of the box is open. After passing through the box, the light is incident on a screen. The following devices may be in the box positioned as shown. Which device could produce a diffraction pattern consisting of a central bright fringe with a parallel secondary fringes that decrease in intensity with increasing distance from the center of the screen? So we have to see which options will cause diffraction. So the definition of diffraction is that diffraction is the spreading of light when it passes through a narrow opening. So in these options we have to see the option with the narrow opening. So option A is convex lens. There is no narrow opening over here. B is concave lens. Third one is a thick sheet of glass. We have a narrow opening in option D, and in option E it's a prism. So for this one it will be option D, the answer. So it's correct. So whenever a light passes through a narrow opening, it will spread apart, and this phenomenon is called diffraction. So now let's move on to the next one. Alright, so here's the next question. In this question it says we have been given a figure. Each of the 4 identical cards shown above is loaded with a total mass of 4 kg. All of the cards are initially at rest on the same level surface. Forces of the same magnitude directed to the right act on each of the cards for the same length of time. If friction and air resistance are negligible, which card will have the greatest velocity when the force ceases to act? So all of these cards have the weight of 4 kg, 4 kg, 4 kg, and 4 kg. They have been pushed towards right, all of them. When the force will be removed, and the air friction and the air resistance and friction is negligible, so which card will have the greatest velocity? So in this question all the cards have the same masses. So the force in the forward direction will be same, and there is no force in the backward direction due to the friction or the resistance. So all the cards will be moving with the same, so their velocity will be same. That will be option E. So let's check it, and that's right. So now let's move on to the next one. Alright, so in this question it says the half-life of one isotope of radium is about 1600 years. In a given sample of this isotope, 15/16 of the radium atom will decay in a time most nearly equal to. So we have to see that 15/16 will be decayed and the remaining radium will be 1/16. So we have to work out the time, in how much time it will, this much amount of radium will decay. Alright, so let's suppose we have 1 kilogram of radium initially. So after 1600 years the radium that will be left would be 1/2. After another 1600 years there will be 1/4. After another 1600 years there will be 1/8, and after another 1600 years that will be 1/16. So 1600 years, 1600 years, 1600 years, and 1600 years. So the total time that it will take will be 4 times 1600. So that would be equal to let me check. It's not 16,000, it's 1600, so it will be 2 zeros. So it will be this one, 6400 years. So let's check the answer, and that's right. So it will take 6400 years for the sample of the isotope to become 1/16. So after these much years, 15/16 of the radium will be decayed and 1/16 will be left. Alright, so this is it for this question. Now let's move to the next one. Alright, so here's the next one. It says a block is pulled along a horizontal surface with a constant horizontal force of magnitude F. The surface exerts a frictional force of constant magnitude F on the block. The graph of speed v as a function of time t for the block is shown above. If instead the block slides without friction but is pulled with the same horizontal force of magnitude, which of the following would be the possible new graph of speed as a function of the time? The dashed line represents the old graph. So in this question it says this is the graph of a box that is being pulled. So this is the graph with the friction, and if the friction is removed, what will be the new graph? So it's normal that if there is no friction, the velocity of the box will be more, it will be higher. And so for this one, let's see the options that we have. So when there is constant friction, the velocity will be lesser. When there is no friction, the constant velocity will be higher. So in this case, the most likely option is option A, but let's see the other options as well. So option B says that the velocity will decrease. You see, sorry, the rate of change of velocity will decrease, and this doesn't make sense, because this will happen if we put more friction. So the velocity, the magnitude of the velocity over the period of time will decrease. So this is not the option. This cannot be considered as the option as well. And option E, that doesn't make sense. So it will be option A. When there is no friction, the rate of change of velocity will increase. So it's option A. That's correct. So now let's move on to the next one. Okay, so it's similar to the previous one, but with a different question. A block is pulled along a horizontal surface with a constant horizontal force of magnitude F. The surface exerts a frictional force of constant magnitude F on the block. The graph of the speed as a function of time for the block is shown above. Which of the following shows the graph of acceleration A as a function of time for the block? So acceleration, if you have to find out the acceleration from the velocity time graph, that is the gradient. So the gradient of velocity time graph is our acceleration. So for this one, you can see that the gradient of this graph will be a positive constant number, because its gradient is constant positive number. So it will not be option A, it will not be option C, it will not be the other options D and E. The correct option will be option B. There you go. So the gradient of the velocity time graph gives us the acceleration, and if we calculate the gradient for this graph, we will get a constant positive number. So that will be option B. So this is it for this video. Now I hope you like it and you understood the concepts. Thank you so much.